Hey guys, what's going on? So, I remember I attempted to do this recently in the past. Yes, there's no sunglasses on for this one because it's not that's necessarily a serious stream. I actually want to get this stuff right, and if my glasses help me to actually see what I'm about to do, I'd be totally all right with it. Okay, maybe it is okay. Uh, there is hindrance to the vision there. What we're gonna do is we're gonna go through, and we're just gonna do this as a little bit of a work log. Why? Because Stephen Wolfram is a crazy enough person to have done this and had hours long work logs where he might just be trying to figure out stuff for physics. And I need to get this done before I leave. So, let's go right into it. Let's calculate a few constants in nature. Where were we? We were at. Uh, I'm sorry. There's many tabs. I'm just showing the notebook we're working on. Hey, nerdy. Thank you for joining. All right, so we had the electric constant was our last one. All right, the atomic unit of permeativity. So A perm. How very aptly named. Oh God, notation can be very interesting. How you doing, nerdy? So what I'm literally doing is I'm literally copying the little things that has out of the book. And to be fair, it's already got a lot of the information there. So what I'm literally doing is I just took a screenshot. I'm going, I'm going to the screenshot that I just took. I'm plopping it in here. Oh look, there's a perm. And since I'm lazy and hasn't figured out how to set the default Times New Roman and everything, I copy and paste my last little thing. I toss the little thing there, and then we change it to. I think that's spelled wrong. Let's see. I think that's only one T in there. Hold on. Atomic unit. I like capital letters because they. I don't know. Let's see. Is that correct? According to our friends at the Googles. I think that's one T. Oh, no, that's correct. Okay, never mind. I'm terrible at spelling. All right. Over there. All right. So this is taking me. I feel like the king in Monty Python: The Holy Grail, where it's like they said you couldn't build a castle in a swamp, but I built it anyway. I went second to the swamp, so I built a second castle. That one burned down, fell over, and then sank into the swamp. But the third castle, yeah, I either lost the file or got confused or didn't forgot to save something or it crashed, and I had to recode this a bunch of times just because not everything is in Wolfram Alpha, and just so people can see exactly where the numbers are. It's like this is coded out, or occasionally I still rely on Pi for Wolfram Alpha because you can. There's a little link in the doobly doo for at least everything up to this point. So if you want to follow along, basically this is going to be how like I'm kind of accounting for like all the different equations, so then we can also group them up, use a list function, sort them, and just have it on the website. If people want to play along, power to them. But and then on again, hey, I have no idea what you're talking about, nerdy. It wasn't me. Uh, okay, where was I? Okay, so what we do here is I need to go into my notebook. Atomic unit of permeativity. Where are you? Atomic unit force. Atomic unit of permeativity. Okay. All right. Now Casey got me all these cool little symbols and everything from where was it? Not Codata. Blah. Those other people. Unicode. There we go. See, I can only do so much computation. All right. I really need to just find out how to just set a default font. Uh, it's all right. It's all right. You gotta learn sometime. Now what are we gonna do? Okay, so now we do our little equation. So this looks like a flip of what we just had. Time charge length. I think yeah, time charge length. So okay, I'm gonna cheat. I'm just basically gonna copy the code right here. Oh, hold on. I need to actually run my code. Derp. Because otherwise nothing will work. See? Those are the mistakes that I kept making. I was like, why is this not working before? It was so frustrating. I'm slowly learning how to code like 2 or 3 years later. All right, there we go. All right, the code is wrong. Hold on, let me correct my errors because I'm a terrible person and I'm still so noob in doing that. Okay, as long as they worry about the protection and everything. All right, we'll fix that at some point. At least we know it's there. Okay, run it again. Everything should be smooth. All right, yay! It computes. All right. So now, once we have our code over here, we'll paste that there. What do we need? We get rid of our 1 over 4 pi. We don't need u. So we have, okay, length, -3, so it's in the denominator. Mass -1 there, and then times squared, charge squared, 1 minus domino tiling divided by 6. Theta there. We can have our little inversion boundary. Compute. All right. Let's see. All right. So, what unit is that? That's in seconds. Hold on. That's not 8. Oh yeah, that is 8 prime. Seconds, colds, meters, kilogram. Oh, that's okay. Thank you. It's yeah, because if you do 1 over pi that, you'll get the it'll be 1 electric constant. There we go. Okay. That's what it. Oh, that's all it literally really is. You just take the prefix off. Huh. I feel like I knew that. I've come at it from different. Okay, cool. All right. So, what number are we looking for? The number we're looking for is 1.11. 1.11. 265. 265. 005. 005. 545. Or 545. Hold on. 5352. Okay. So we get error 1.7. So we go down to 3. Okay, it's in the error bars. We have error over there. Okay. 5 or 2. Hold on. Okay. Just because some of these things have been updated, so maybe the 13th or 14th decimal point, there may be maybe a tweak there. Almost everything should be good, but when you want to be open and transparent, okay. So we've got our magnitude right there. It gives us this thingy right here. Let's copy that. All right. We'll go down here. We'll toss this. Toss this guy over here. Paste you. Don't need all our boxes and all that jazz. Let's follow the notation and see if we get the same thing. Dun, dun. Sorry, I'm listening to my Dragon Ball Super music in the background. Let's me focus. Okay, so what do we have? We have seconds, just for the units and everything, because I'm just following what it says right there. All right, seconds squared, coulombs squared. All right, and then we got meters. -3 because it's the denominator, and kilograms. Raised to the -1 because it's the denominator. All right, let's run a compute on that. Make sure we get the same thing. All right, 1.2654. Okay. All right, so it's coming out to X. All right, there we go. All right, we don't need these guys here. All right, delete that. Groovy. All right. That notation works easily in there. So, again, since I'm too lazy to learn how to set a dang default text. Yes. All right. Toss you in there, run you there. Cool, you work. Boom. Boom. And we add you to our compilation of code down below. Dun, dun, dun. Computation. Totally worth it. Alright, run you again. Alright. Next victim. Where are we at? Preview. Alright. Atomic unit of permeate. So we got you. What's our next? Molar volume of ideal gas. Oh, 273.15 Kelvin. That's what we consider room temperature. Alright. Yes. The stream name on a Saturday of computing the standard model with the Wolfram language. It just screams excitement, doesn't it? It's okay. It's okay. Everybody you just do what makes you happy. Let's have, oh god, I'm on the run by the notebook. Let's see. Personally, I'm a fan of long game. Alright. Just an opinion. No matter what you do, just play the game to your best. That's all I'm gonna say. That's a lie. I say many things. Alright, so atomic unit. No, we're actually on. What am I looking at? Molar gas volume. Okay. Yes. What's more exciting on a Saturday evening than the molar volume of ideal gas? 273.15 Kelvin, or 100 kilopascal. I cannot do the talking and the typing thing at the same time. Wow, I'm terrible at that. Alright. Our other thing. What the ideal gas? Deal. A lot of space. Oh, that's very interesting. What the? Don't mind me. Save this guy for later. Yeah, Beetlejuice totally didn't influence me at all. What is that? Nope, saving for later. Alright. Okay. Yes. When you totally have the ADD. Here's the thing, nerdy. You, my friend, were an early adopter. You were talking about magical words and code before, I'm like, I don't know what he's saying and stuff, but there seems to be a trend. And I wanted to get into it, but it still seemed too hard. Now with ChatGPT and everything, it's like, okay, as long as I can try to communicate something, and something has some interface to interface with something else, as long as you get the general groove and vibe, you can do literal wizardry. That's what I always like to call myself. What am I, a pathfinder? What are we? We're like Jedi. We just require more kyber crystals. It's just religion can make things complicated. I'm just saying that. It does a lot of folks well. It doesn't necessarily do well for everyone. Just opinion. Yes, and the controversy. Yeah, hey, just gotta ride that cosmic wave function. Whether that's an hyperbolic or a true statement, I have no idea. Here we go. There's our molar volume. Thank you, Casey. Alright, so we go down here. We do all these little tips and tricks, these macros and everything. Oh god, it's just like gaming. It's like, even when you need to grind out things, it's like, when you knew how to do them better, it was so much more pleasant. Oh god. Being an ice mage and leveling up in the Outlands was so great. Once you got the frost powers, it's the warlock that you were terrified of that would destroy. Oh, it's ice lance. Oh, I have some minions too. You're getting frozens. Yep. Patches never break a dang thing. There we go. Okay, so we got that. Now we need to do our equation. What do we have? Oh god, we got a crazy one here. Alright, so what do we got? We have 1 over J1 and J2. J1 Your one's there. We gotta leave a space, because otherwise it views them as a single object, and then it does not compute. Took me a while to figure that one out. Alright, the 2 is squared in there. Alright. Go back and change the font after. Let's make sure it all works first. Alright, so we got 2 KLR. That is this guy right here. Something in line. Yeah, it's some type of symmetry thingy. Yes. It's the things we'll add in all the extra things later. Alright, so we need another bracket over there. So we gotta divide that. Now EV. Now which EV? The electron volt. There may be similar notation for some of these things. We try to differentiate. Okay, the EV. Hey, maybe the one that says electron volt. There we go. There we see. That's why I put in there. So I didn't always. I can look at the things and be like, oh, there's a translation. It might not be the exact same font, but we're trying to keep everything kosher. I don't know. I apologize. It's Hanukkah. I think I'm allowed to get away with it. God, I'm a terrible Jew. Well, totally going to hell, but on the bright side, maybe I can make things a little bit better before I depart this mortal coil. Well, I think that's what most folks want. You just all go about it a little bit differently. And some people are willing to listen, to have me just kind of ramble on. Yes. Well, hold on. Bore radius and fine structure constant are in there. Well, this is actually the Wolfram. Here's the thing. I give a bunch of money to Wolfram just because I'm like, these tools that literally are for free, just also for like the extra computational time. So if I want to look for a close form for something with a heck of a lot of significant digits, the notebooks they seem to time out after a while, depending on the kernel you're running. For keeping track of things, it's just a very simple thing. And yeah, I think the Jupiter or Juniper, pretty much very similar style. I have heard folks say good things about them, to my recollection. But actually, you know what, Nerdy? If you're still there, we could actually even jump ahead if you want. Because if this system is set up, as long as even if I do have to solve something else, everything now is just do it. So let me just finish this guy first. So this length, we need the mass of the electron right now. Computed that earlier because it's basically one of the primary derivatives. So it's like whatever that is, well, we got to build pretty much everything else mostly off of that. Where are you? So many. Okay, here we go. Yeah, that was the first derived thingy there. Okay. So Planck length squared divided by the mass of the electron. Okay. Now we have 1 minus, that's red n, which is set equal to 5, but just for noticing for us, we have that in there. And that's divided by the rabbit constant to the 5th. Ooh. Let's see. R is for rabbit. That's good enough for me. Alright. Oh, God. We're changing the division to red. The redness is spreading. Where are we? Alright. Color. Go to black. Yeah. Alright, so get that. And then we raise you to a red N. Because we can. Boom. Let me just steal that color for a second. Shh, leave me alone. I apologize for my colorism. Yes. Alright, so let's... Do we need that? No, we don't need that bracket. I'm going to live dangerously. And we're going to get our J theta there. Alright, throw you in there. Oh, and that's raised to a red N. There's a lot of 5s in this guy. Oh. Alright, and then we need our inversion box. Planck length, Planck map. God. I have no idea if what I noticed the other day about that is true, but I'm probably going to post a video that's probably wrong. But context is important. I'll leave it at that. Alright, we got our box there. Alright, that I think should be it. Let's see what happens. Alright. So, what is it? Meters cubed per mole, I think it's a unit. Let's see. Mass, length, time. What do we have here? Alright. Let's first look at the number, because units we can do wizardry with. Alright, so that's -2, so we gotta move the decimal over. So it'll be 1, 2. Okay, so those are 227, 227, 109, 109, 546, 546, 4, or 5, 6, 4, 6, 5, 1. Okay. So we got a bit of a little deviation there, but get out to 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, get the 9 digits. They're saying that that's off there. Okay, now, reasonably, maybe it is a little bit more. Could be wrong. That's the deviation currently. Okay. I'm still waiting on that 2022 data. But, all right, so, all right, that seems to, at least we got our error there. We want to be open and transparent. Okay. Actually, looks like it went up by a hair because we recomputed the electron. I think the last couple of digits was, we actually can even, there's a computational equivalence between that and like the Laplace limit for what we used. So Laplace limit, I think, makes it a little neater. Okay, so let's make sure we have, now what are the units that we have here? Meters cubed per mole. Okay, so let me literally just take this, plug it into just Wolfram Alpha. It's the browser one. Let's see what we get. Oh God, so much text. Yes, thick spacing. I understand you're a thing. I don't really. Hold on. No, I want the units. Where are we? Okay. As long as the units are right. Sometimes it will infer a different. Oh God, so many thick spaces. All right, so we got that. All right, so seconds to the fourth. All right, yes, I don't need that negative spacing there, not that slash. All right, I think that's right. Let's see what it comes up with. Now seconds is a unit. Let's see. Okay, kilograms, meters, multiplication. Okay, so it has seconds. All right, seconds to the fourth, over kilograms, meters. Okay. So, what is this? Meters per mole? Meters cubed divide by mole. Cubic meters per mole. Okay. Length 3, amount -1. Oh. How do we get this to... What's the expression actually say? It's 2 meters per mole. Hold on. If we take these dimensions, all right, time 4, mass 3, okay. How about this? Let's ask Wolfram Alpha. 2 meters cubed per mole. Hold on. And not compatible Y. So we have length, amount. Molar. All right, wait, is this a ratio? Molar volume. Oh, it's a volume. Meters cubed divide by mole. Hold on. What if I just express it in moles? In moles. Maybe I'm trying to force it into something. Amount of substance. Molar volume. Wait a second. That should be equivalent, but hold on. I just need to look at the dimensions. Because I was getting lazy and hoping it would do the work for me. Alright. So, in order to go to that, we need to go to moles. So, let's duplicate this. Dimension of moles or meters cubed per mole. Okay. Meters cubed divided by moles. Yes, the moles will divide them all. And I hear the rodents will be there as well. Technically, I was born the year. Okay, so length minus 3. Let's see. So we're at length minus 3. And then amount. How do we convert to them? So I need 4 times, negative 4 times, length minus 1, and then mass minus 3. Wait a second, the 45 times the molar ideal gas? Wait a second, isn't that what we just calculated? Length 3, amount 1. Cubic meters per mole, so inverse molar. Hold on, is that what it was before? I'm tempted to just label it and go, because sometimes, but I also want to understand this, or at least be able to compute it. Moles. What if... Wait a second, what if we just divide it by moles? Isn't that what we tried? Divide by mole. This is moles per molar volume. So I mean meters cubed over mole. Wait a second. Put this on the number, kilograms, seconds for time. Oh, the dimensions just still seem... How do we... what's the mass per mole? That's what I'm missing, because we need to swap the mass. Molar mass. Oh, mass and amount. There we go. And it's cubed. Okay, here we go. Yeah. Molar mass. Oh, molar volume, molar mass. Derp. Okay. So, we should just literally be able to take molar mass. So if we do molar mass, doing it on this one before we do it in the notebook. Let me just see. So I think unit. Alright, yes, exciting stuff. Wow, that got rid of everything. We just got time to the 4th. Alright, well that did something. I think it's 1 over molar mass. Let's see if that does it. 1 over molar mass. Just because ultimately, like, this is the thing that really can hold things up. It's like, alright, if I'm going to compute it, it should compute. If it's right, it's like, can I just do the dimension thingy after? Sure, I can. We're already making some assumptions. We want to have the strongest case we can. Okay, well, that didn't really seem to matter. Wait, why didn't that... Oh, it's... Hold on. Oh, this is... Yeah, it didn't... Hold on. Let's write this out better. Alright. Hold on. Actually, no, let's just... We have a freaking notebook. Let's do it this way. Let's It's 1 over that guy, so let's just throw molar mass, capitals, molar mass. Okay, well, let's do the computation. Let's see. Oh no, it's getting confused now. Mass meters. Oh, one of those guys. Hold on. Let's, yeah. Let's not do all that in there right now. Okay. So we'll just I'll copy our friends again. Alright, so I got seconds to the 4th. Seconds divided by... Hold on. God, it's so messy. Kilograms. -3 and meters raised to the -2. So that is like the best thing for me to like try to learn things. Wait a second, what are you doing? Molar mass. Should probably actually. Hold on. Let's get these dimensions first. Boom. Okay, kilograms, seconds, blah, 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 blah. Okay, how about this? Let's take all that. Let's divide by molar mass. Yes. The rabbit constant. Yes. See, I like the universe, the imaginary goat ratio. I still need to do a video on just that. That's, it did help us find a really good match for, I think, the classical radius of the electron. But I think we found something better, or Thad did. Molar mass. Right. So mass minus amount. Okay. So let's do this. Wow. All right, so what are our dimensions? Mass and amount. So what do we need to get to? What the heck are we thinking? S minus amount. Okay, let's just do it. Let's do mass amount raised to the -1, because we can. Ooh, they do not like this. Oh, wait, no, I'm supposed to use kilogram. You need to use the right dimensions, come on, memes. Kilogram. Yes, it's alright, I've been that guy. I've also been the guy that passed out on, outside of the party. Because I was ordering pizza to avoid getting the spins. I forgot to hit submit order, so the pizza came 20 minutes late right after I got the spins. It's alright. The hostess was nice enough to throw a blanket over me so I didn't freeze outside. See? Folks in Utah are kindly. Kilograms. Amount is a mole. Moles -1. Oh god. Moles -1! It's the new Godzilla. Oh my god, that actually worked. Oh, I was just forgetting the moles the whole time. Don't forget your moles. Are moles a rodent? Moles. Actually, to be fair, I think Stephen Wolfram's favorite unit is actually moles per acre. Which, you hear moles from a science dude, you're like, oh, he's talking about the molar volume or something. No, he's talking about the literal average moles living in the ground per acre. It's... moles animal. Very small mammals adapted they have cylindrical velvet bodies. Oh, small is confused to size. Oh, look at them, it's so fun. Oh, yeah, no, you can't see. Are they? Known as rodent? Small muffs like... Oh, they are. Oh, the adorable little fluffers. Oh, hi, Stephen. How are we doing, my friend? I'm trying to figure some stuff out, so, well, hold on. So now, where do I need to adjust my mole? Whatever is mole 1 or mole square... No, it's gonna be moles cubed! Hold on, let me... I think I already answered my thing. Hold on. I'm just testing it over here in the side window. Alright. No, it's must be moles to the -3. Yes, moles -3 is the answer. No, it is not the answer. Kilograms, seconds, reciprocals per mole. Do I need kilograms and moles? I'm confusing myself. Yes, there is. Oh, pizza is a good one. The rodent constant. That's the right. Well, it's wow. I have the right numbers. I just want to write the right things on them, but I don't. Hold on. So let's do this. All right, let's actually entertain the people because we're trying to figure something out. Let's see if we can't figure it out. So moles. How about this? Kilograms, moles. Yes. All right, let's see what this does. Will this give us our right dimensions? Oh, we had the right. What were the dimensions we needed? Oh, wait a second. Oh, we had those. Oh, what the heck dimensions am I trying to figure out? No, don't mind me. Okay. Dimension mass -3, length -2, time 4th. Okay. So let's delete this from over here. Let's run this over here. Yes. Mass -3, lengths. Okay. So to go to moles, we need to... What is this? Oh, meters divide by mole. Oh, so we need to get to meters cubed divide by moles. Okay. So... so we need meters cubed divide by mole. Mole, mole. Mole, mole. Mole, mole. Molar volume. Okay. So molar volume is length to 3. Okay. So I need to go down by 5 lengths and 1 amount. Okay. So to do that transformation, I need to meters 3 by divide by meters 3 divide by mole. Well, let's see. Let's see if this does something. Go over to our other side, a little test thing. Let's see if this balances any dimensions out. Let's see what that does. That did not. Oh, that gave us -5. Alright, maybe I think we're supposed to multiply. Yes. Apparently there's only so many different combinations. There's a lot. Okay. It's mass -3. I need to go down by 2 more there. And then that is the right time. Okay. So I just need to subtract 2 more. Molar mass? Let's try this. Molar mass? I know. I'm so exciting. Seconds to the 4th. How do we get time length? Is that even the right expression? Okay, I should look. Is that... Oh, wait a second. Is that meters divide by moles or molar volume? Well, let's try this. Let's try meters cubed molar was gonna say this would have been like the first time where something actually completely worked out. Of course. There we have issues. Oh, that just leads to moles. Meters cubed by moles is... Oh. Amount. Okay. So, is that what I need to multiply it by? Let's try this. What do we need to get to for moles again? Moles we needed. No, you're not the moles I'm looking for. Hold on, don't mind me. Go there, mole. Mole is amount of substance, SI base unit. Amount meters cubed per mole. Oh, it is molar volume. Alright. So then we need 3 meters cubed. Okay, so that would bring us to molar volume. Yes. Oh, the combinator. That's how I did, like, homework that didn't have answers, apparently, at one point. Length and amount. Okay, so how do we get to length? Okay, so we need 5 of those. So if we divide it by molar volume, let's try 1 over molar volume. Let's try molar volume. I think that's what we're trying to express. Let's see. Hey, Jez, what's going on? We're trying to... Oh, it doesn't understand me. So, don't feel bad, Jez. You're not the only one. Molar volume. How about this? Meters cubed. Amount raised to the -1. That's what it says. Uh-oh. Oh, I spelled amount wrong. Wow. I don't even know if that even makes sense. Let's see. Nope, it doesn't understand me either. It's alright. Okay, so we have the right answer. We're just trying to put it in the right way. Because computation is supposed to work. Okay, so if we have that, let's just try amount. Apparently that's a dimension now. Let's see. Space. Alright. Oh, it doesn't understand. So it's just like everyone else. I get it. Let's, wow. Just raise this other guy to the amounts. I know, late-breaking stuff. Welcome to being a physics monk. Raise to the amount. Hey, get some rest, Jez. Oh, okay, so that brings us time to the 4th. What if we just multiply it by amount? Oh, mute mole. Amount is, oh. It's literally, I just need to multiply it by mole. Is this what it is? Because this looks like the right dimension. Hold on. We need... this one is 3. Huh. Okay. Maybe I was making a big fuss out of all this. Because isn't this all just literally just divide by mole? Okay. Well, looks like we went on a mole chase. Because it's literally, you just divide it by mole. Yes. And the dimensions line up. Okay. So all I literally needed to do. Oh, you guys are gonna love this. Mole raised to -1. It literally is mole -1, isn't it? Seconds to the fourth kilogram meters squared mole. Okay. So, but why is that? Why is it still expressed in m cubed? Divide by mole. One mole. Molar volume? Divide by mole? Do I multiply it? 1 over mole? No, dividing it's the same as 1 over. Molar volume? This is meters cubed divided by moles. Oh, let me just check this constant. Let's see. Sometimes maybe the dimensions changed. Who knows? Probably not. Let's go to data. M3. Oh, yes, it is divided by mole. Okay, so meters cubed and mole -1. Okay, so that should be meters cubed and moles -1. Okay. Okay, so we need 3 length and then -1 amount. Okay, so we need to get rid of length, so that's we need to invert that. So hey Mana, what's going on, my dude? Happy holidays to you. I'm just trying to figure out this dimension thingy. Mass, length, time. Alright. So that, and then molar volume is molar mass. How about volume? All these different things that I'm learning. Alright. Length and amount. Length and amount. Okay, molar volume. And then moles. Oh, you're just expressing it a different way. Oh, wait a second. That's how many. Oh. If we divide by that, so we gotta multiply it by molar volume. So we did that. That'd be 3. Wait a second. Mass is a thing. Where's molar mass? Okay. Kilogram per mole. So we need. Okay, so we gotta do this way. So just over molar mass. Let's try this. So the denominator. Mass length amount angle. Ooh. Oh. For mass, where the milliseconds art for no. What's a mums? What? I don't know what just happened. Kilograms. I just did the molar mass. Why is it saying there's only one S there? Why? Why is this broken? Why won't it just do math? Hold on. Wow. This did I break Wolfram Alpha? Wow. I'm just gonna break it up into its dimensions. Meters and amount minus 1, don't I? Okay, so it's gonna be meters and then moles. Wait a second, it's meters and moles cubed, isn't it? So -3. Went back to there. Let's see. I know, the most exciting stuff. I know you can't even see what I'm working on right now. It's so bad. Hold on. I'm missing something. Molar volume, ideal gas, okay. Standard cell volume of ideal gas is most remembered and least useful number in chemistry. Three, and then m divided by blah, 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 blah. Okay. So I do got to go from 3. Okay. I'm going to go from -2 dimensions to that. Wait a second. What is this? Oh. Yep. It is 1 over the Juz. I guess it's her primary action there. Okay, how many dimensions do I need? Hold on. Move that there. Okay, mass 3. Length -2. Okay. So every mole, kilogram per mole. Standard unit. Mass base minus amount. Okay, kilogram per mole. Alright, so what if we just do kilogram per mole? Let's try this. by moles. Let's see if we do it this way. Yes. Wait a sec, how about moles? Moles per kilogram. Sometimes semantics make a difference. Wow, I know there's such a simple answer to this. Is it just the energy? What's molar volume? Am I using the wrong electron volt? Hold on. I think there might be. There's another expression of it. Slightly different. I think one was joules, and if I just change it to electron volts, will this change it? Is it really that easy? Let's charge EV divided by H CV atomic velocity mass electron C. Do I actually have the right things in there? Let's see. 1 over J1, J2 squared, blah, 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 2 kLr divided by the electron volt squared, blank length squared divided by mass electron, 1 minus the rabbit stuff, okay. Square meters. What if I took out the 1? Nah, that changes it too much. Nah. So at least gotta have the right number. Oh wait, joules derivative. Oh wait, meters derivative. Wow, how very embarrassing. Let's okay. Will it give me the meters derivative? This is, I mean, come on. So that's all it's doing. If it's just like, oh, you could have had you wanted the derivative. Oh, no, we can't just give you the thing you're looking for. You gotta struggle on it for about half an hour. All right. There it is again. All right. Let's go to meters derivative. There we go. Why does it just keep showing that guy? Yeah. That's cool. Yeah. Why won't you just stay at whatever derivative I want? Okay, yeah. Meters derivative. Yeah, okay. Why won't you send it to Wolfram Alpha, though? Oh, I can do kilograms derivative. Let's see what that does. Well, that's not... Hold on. Right dimensions, the wrong times. Yes. It's okay. I've been struggling just as much off. No, it usually goes a little smoother there. I know, I should probably actually check to see if there's some messages. I was looking to maybe do a cosmic council later. Hold on. Okay. Yes, as I completely ignore. Yes, I just realized I'm still streaming as I'm talking to somebody else. Yes. How to run the most boring show on the internet. Okay, I don't even know where my window is. God, what a terrible host. It's okay. Nobody's watching. At least somebody's watching. All right. So, at least that'll be interesting. Um, if it's somebody I know and happens to be pop into the chat, we may have some question times because I think we had gonna have Mr. Brad Voorhees from the Sonic Gravity podcast. He should be popping on in about an hour. So let's see if I can figure out this one little thing. And in order to do that, I need my anime music again. Where are you? Dragon Ball Super, take it away. There we go. Just low, soothing. Yes. Okay, so now how am I supposed to change this? How do we go from do I have these dimensions? No, I wouldn't have made the, let's see, hold on. Line squared over the mass of the electron. Should those be swapped? Just say, hey, Bone, yes. Somebody's gonna keep me honest. Thank you. Let's see. God, I would play some music, but the only thing I have currently that just fit was the Monsters. The Power Rangers just missed by like 12 seconds. I need to edit it down. Alright. So. Why won't this. Joule's derivative. I just want the meters derivative. Okay, hold on. Let me just take this. Boom. Turn into code. This isn't what I'm looking for. It's not. Does kilograms force make it? What did that even do? That changed time. Well, that changed. Wait a second. Is that what I'm looking for? Is that why I'm so confused? So we gotta express in force meters. You gotta become computational Jedi. Is that what's going on here? Alright, let's try this. Kilograms force. Okay. Well, that gave a lot more time. It's not what we're looking for, though. So in order to get rid of, pardon, in order to get rid of mass and go to that, we need molar volume. Okay. Kilograms and mole. So we need, okay. Wait, is that what we do? It's not kilograms per mole. And then if we cube it, I don't know what this will do. Cube it. Let's see what happens. Well, that changed some things around. Kilograms divided by mole. Maybe then. Okay. How about this? Let's just kilograms cubed. Well, that'll get rid of our negative mass. Our negative length. Okay. Now we just need molar volume. Oh, we're at length minus 2. We need to go up to okay, so we still need meters cubed. Length and time. How the heck do we? I don't know how to get rid of the time thing. Well, no, I know how to just seconds to, oh, per mole. And molarity. Oh. Oh, that's okay. Moles per liter. Why does that look like that might work? If I divide that by moles per liter, I'll get us up there. Because I need to go to abscirc. Length and then time 4. That's a unit? Abscirc. Hold on. No, it's too much effort to share. I'm sorry. I just really want to just figure this out. I'm probably just gonna sign off with having failed yet for like the 3rd or 4th time trying to do this. Wow. I swear I was able to totally do it earlier. Okay, so. Hold on. Meters cubed moles minus 1 gives us a length cubed and amount minus 1. Cubic meter per mole. So molar mass. Oh, let's do it molar mass. Raised to the 3. Oh god. This is gonna be so messy. Molar mass, meters per mole. Is this gonna cancel out? Oh my god, it did. How the heck do I apply this? Alright. Do I just apply it? Let's see. I mean, this is absolutely crazy. Let's see if this works. Alright. It's like all these hidden intersecting directions and stuff. Well, that didn't work. Alright, so let's do, hold on. Before we go to the molar mass, let's let's stick with meters to the moles, because those are the actual dimensions that we are trying to figure out here. Okay. Nope. Alright. So let's try swapping those dimensions. There's only so many types of permutations we could do this to try to make some sense. Okay, so let's get rid of that. Let's just try molar mass. Raise to the third because we can. Because we need to get rid of that pesky mass unit. Oh my god, didn't even... Why is it not even getting rid of them? What? Why is it using milliarc seconds? Oh my god. Oh wait, that's moles per kilogram. Hold on. Molarity. No. Molar mass. Kilograms per mole. That's right. No. Molar mass. We need the right units. Kilogram mole. Alright. So, kilograms. Raise to 3. Mole. -1. I think we already did this. Let's see. Looks like it might be somewhat more appropriate. Okay, alright. Length 2, so we need... Is that length and time to balance out? Okay, we got the right amount there. So we have molar volume. Give us our... Oh, we're gonna need more than just molar volume. We need... hold on. Where's molar volume? Molar volume. Length and amount, but we need change. We need meters. This might do it. The units. Alright. So we need meters per mole. Okay. So if we do what's the exact notation? Meters cubed per mole. What's molarity again? Molarity. Length minus 3. Oh, per liter. Meters. Meters cubed divided by mole. Alright, let's try it. Meters cubed. Maybe I just need that. Let's see. That'll help our dimensions a little bit. Alright, need 2 more dimensions of length. And get rid of our time. The upcycle. Yes, that is very... Actually, it's... Well, we might get into that. I think that might be one of the square ice constants or something there. We'll get into that soon. Alright, I need to go do dinner and stuff. Alright, so I totally failed at this again. Of course I... Oh, excuse me. No, I think we did one. I think we actually did well at one of these guys. We had one new unit, and then we totally got stuck on dimensional conversions. Just because I'm like, I could see that. I could just relabel it. There's got to be an easy transform depending on how we're looking at it, so... At least the numbers are right. That's That's good. But, yeah, computation don't really let you cheat like that. Be like, yes, yes, this is totally fine. Look, here are the numbers. Well, yeah, you plug the dimensions in after. Okay, so what if we did... blah, blah. So I don't just want to add a whole bunch of seconds and stuff like that. There's got to be an easy... Hold on, is there moles per second? Molarity, moles per second. It sounds like the sequel to Night of the Lepus. Moles per second. Time minus amount. Okay. I guess maybe I'll just have to apply all the dimensions and we'll see. That's how we view it. Alright. Hey, if we're just going to do that, well, then let's just do that. Let's say, okay. Kilograms. Oh, let's compute this dang guy. Let's see what we need. Let's do our little conversion. Okay. Boom, go. Here's our answer. Hold on. If I change this to electron volts, let's see. Oh, meter square per kilogram. Okay. Oh, that changed it. Okay, but that's not what we're looking to do. Hold on. Run you again. We need to save there. Not that this should really make a difference at all. In case it makes a difference. Every once in a while, a few more braces can be healthy. Alright, we got that. Alright. So if we wanted to do this, here's what we would do. We just literally look there. What do we need to get to? We need to... Kilograms. I don't know, maybe this is all perfectly fine. Kilograms. Raised to the third, so we need to have no dimensions of mass. We need to have meters to the sixth. To the sixth. Seconds. Raised to the -4. Actually, I should probably just check to see if this was a dimension. And amount -1. Or moles. So -1. Actually, let's see what that is. Mole seconds. Oh, God. I mean, I think this should actually give me the exact right answer that I'm looking for, but... put a note there, let's see. Because, I mean, I've done that like hertz and volts and seconds, but I mean, is this how we really need to quantify it? We just adjust our dimensional things till it's meters to the fourth per mole. Wait a second, that's actually really close. We only have one more dimension at a time. Wait a second. Is this what we do? Is this what we've come to? Or just setting the different sampling parameters of reality so we can say it looks all nice and pretty to us? I don't know. Oh, well, that did something. Oh, there we go. All right, boom. What? Oh, no. It wasn't seconds. No, that's to the fourth, meters to the... Ay. Oh, can't even do the arithmetic. Trying to claim, you're trying to unify different things. Yeah, you spent an hour trying to figure out this dang thing. Okay, cubic meters per mole. Boom. All right, there's our answer. Why? Because we needed to adjust the dimensions that we looked at it with. Okay. Yay! Only doing the... Human's gonna human. All right. So we got that guy, so we did 2. Alright. So we just take... Alright. Take our answer there. I'll plug you in here. Paste you there. Alright. Alright. So let's put in some SI. So that means we take... hold on. 3, so... Alright, times 10 to the negative 2. Alright, times 10 raised to the negative 2. That's how they did it. Alright. Make sure we get at least 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Cool. Alright. Grab you, grab you. Alright, and that's meters cubed moles minus 1. Mole minus 1. Mole meters. Yes, yes. You know. Moles. Such misunderstood creatures. Morgara was a good one. Morga? I don't know. The mole dude in Breath of Fire. The first one. Get some cool claws. Okay. I had you all there. I did that. Boom. Moles. Moles. Many moles. Alright. I know. I shouldn't have even streamed this. Wow. Disappointment to Professor Wolfram. I figured I would be flying through this. That's okay. He has done enough streams where it's literally like, it sounds painful to be on, because it's like, things aren't going right, and you're like, what's happening? Oh god, now my mole meters aren't working. Why? I need to... let's see. Meters cubed. How about this? Per mole. Let's see if that works. No! Why? Why don't you understand my moles? Let's see. Gives me the right thing. Hold on. Do I need to bracket you? Maybe that'll help. Let's see. Mole. Let's see, that should be in there. I need to double bracket this. Wow. You do not want to work today. Will it understand mole? No. Does Wolfram Alpha really not understand this? Let me plug it into Wolfram Alpha. It totally understands this. What are you talking about? Why don't you want to work? Meters per mole. It totally understands this. This is very annoying. I just want to set that equal to that. Alright. God, it's... You don't need to actually run that whole thing. It's just... Does it not understand this? No, you understand that. Do you just want M3 per mole? Is that what you want? I'm okay with that. Alright. come on. Per mole. Oh, okay, fine. M raised to the 3 divided by mole. Maybe it understands that. No! How do you not understand? Can you not do moles? Is that... So the 3 is minus 1. Wow. Molar. Oh, this is... I mean, this is just discouraging. You can't even read that? Come on, man. Let me just set this dang variable to this. Meters per mole. How about this? Meters cubed per mole. Molar volume? What? Just moles. Is Wolfram out? Okay, there's gotta be something wrong here. This is very annoying. Wolfram Alpha knows moles. I'm looking at it right here. I mean, come on. Molar volume, what are some other words? Relative volume. I'm gonna try molar volume. Alright, well, I'm just gonna end the stream right now just because this is annoying. Hold on, I'll just save this. Alright. Well, I apologize to everybody for this stream. This is nowhere near as exciting as we should. Hey, Itadri. Yes. What do moles have to do with meters? It's a good question. It's supposed to be the ideal volume gas density for at 273.15 Kelvin or room temperature, 100 kilopascal approximately there. So, yes, I'm still... We got it to work by some... Alright, this is a pain in the butt, so we'll just end that there. So, should be doing an episode of Cosmic Council in a little bit there. Just go grab some dinner, and we'll come back with some much more entertaining stuff. So, peace out, everybody. Oh, hold on. I actually need to end the stream.